Hello student, and this will be the last video about instruction of how using the RapidMiner. The today's session we try to just concentrate on the supervised data mining. This will be one of the very important part for data mining, and most of the case like when you deal with prediction about the classification, this will be the main task of a data analyst or a data scientist. So the agenda hôm nay for today will be like we learn how to just load and clean the data. Because that's the data that I'm going to just try to show you, we have some kinds of the problem and we have to load them and clean them, prepare them before we put them into the system. Moreover, we learn how to do for the data partition. Actually, like I have already instruct you guys how to do for data partition in the previous video for the introductory section of the RapidMiner. But we will try and see one more time how we can do all the process on RapidMiner. Of course, for classification purpose, we have to develop the model, right? And we will have to read and understand about what could be the output and the result of the classification model. We also have to learn about how we can validate the performance of the classification model, compare between the power of different classification model. Are they doing well or are they not doing well? Okay, and the today's session to use the data file, what we were gonna say would be like the forecast prediction. So this could be the data set that's used to understand about the selling of the online product, and we will have to run and see like create for a predictive model that identify all the propensity buyer. Propensity buyer mean that if the buyer will really buy the product in the futures or not buy the product in the futures. So we try to predict who are likely to be the buyer and who are not. Okay, so this will be the data set and you can easily download them from Canvas, and this will be the original data including for 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 different attribute or different variable. Also, we have up to 825 observation will be provided over here for the data set. So if you go and see about the data set, you will see that there's some kinds of problem. The first problem will be like, okay, so you can see there a lot of things will be like just the string data, or I say categorical data, or nominal data. Okay, so like city, right, country, browser does mean the what will be the browser, the purpose we use to search for the web. Traffic source, you got it from like Google, or you got it from Instagram, Facebook, or the other kinds of resource, the social media. Repeated visitors, that means that will be the customer or the transaction has been already sub the web or our website before, and now they repeat their surfing behavior one more time or not. That will be sell or not. That means if one guy they really, you can sell the product for them. Okay, so that should be 0. If not, you can sell it, could be like 1. Here we do with the problem. Of course, here you have sell and the sell value, right? So that means if you can sell somebody, that means this one will be not 0 but 1. But that means also we have the sell value. For example, if you sell for somebody, right? So you can sell it like $25, or some of them will be like $55 or $99 or $50, whatever it would be. But however, it's provide you guys like if you can sell something into the propest, they can provide you some result, right? Some of the result about the sale values. Okay, and finally we have over here the data file called the guy. GU's ID. I am not sure. This will be just the IDs of the data. Okay, tenor, the age of the customer, city where they are. Tenor, that means how long they has been with you. Okay. Okay, so this will be the original data. I will not just fit it. I will not close this, and you can take a look and see about the kind of like the description about the data and what could be the exactly the of the data, what of them will be mean. Okay, here cell will be the label where we try to predict. That should be the touches variable. We're going to just do it, and let's go and start to do it on RapidMiner. First of all, of course, I have to load the data into the computer, right? So I use the CSV file and I import the data. So I just go into the directories where my data has been saved, and it's in VNUK and module number 6, and that should be predict CSV file. Okay, so over here, all the thing has been put into um, the um, the basic default, and you can see like the beside of the problem about the data file, right? We also have another problem will be like the egg. So we have some mixing data here. If you go and check, so we have some mixing data here. So that means we have to if in case like some of the data is still available, so we cannot delete them 100%, right? We have to replay the data, or we do the data cleaning on this one. That's up to us. Okay, and let's go and check and put them into the data. Okay, and this will be all the data, and they have been put into the data type. For example, the GU's ID has to be polynomial, 10 has to be integer, 8 integer, that's true. City, country, browser, traffic source, they will be like polynomial because they just a string. Okay, categorical variable. Repeated visits, 0 and 1, yeah, it will be 5. So they will be picked like the integer. Cell 0 and 1. Actually, I'm not really care about it, the 0 and 1, because I should just display them more, right? Display them more. So like over here with the cell, instead of 0 and 1, I should say like yes and no, something like that. Okay, so this will be another problem about the data. But first, I will just import the data first. Okay, and let's see about the original data, and let's run for this one. I will just make this one a little bit smaller. Okay, and let's see. So this is the original data. And now let's go and deal with the problem about the data. First of all, will be like city, country, browser, and traffic source. They are the categorical data, and with categorical data, you will be fine to use them in the RapidMiner, but that's better for us to just transform them, right? So first of all, instead of I keep them like the categorical data, I will change them. So I will change them by nominal to numerical. Okay, nominal to numerical, and that's mean here I will select for a subset of them. So 4 of the variable, right? Browser, city, country, and traffic source. Okay, so most of them not the guy ID. Okay, yeah. Or before that, I believe that I will remove some of the data first. So I will just select the attribute. Okay, so some of the variables should not be included. So I will just remove the guy ID because I'm not really list them. Okay, so I remove them and I will inverse selection. That means the rest of them will be selected and the guy ID will be not selected, and that should be the data. So now when I'm going to use for the subset, now it no longer has the guy ID, right? And just 4 of the categorical variable will be saved here, and I will select them and I will change them into the unit integer. So instead of putting into the values like that, now I will just put them into the unit integer, and I'm going to run it, and you can see over here, right? Now city, country, browsers, traffic source, that's all has been changed into the number, and that's how to encode the data a little bit better. Now let's go and see about another problem. Egg, right? About the egg, we still have the missing data, so this will be the time for us to just deal with the missing data. So with the missing data, I have the cleaning and missing and replay for the missing data. So with here egg, right? The variable 8, I will try single, and the variable 8, it had a problem. So I will replace them by just like non-minimum average 0 values. Here I will just do it like average. Okay, and let's check. If I run for that now, one more time, you can see the 8, right? They now have no longer the missing values because they replace for all the missing value by their 36. It's the same with what I can do on Excel, right? So if I use for this one, go into the end of everything, and I want to have about the average of the 8, and I use the average function, and I select for all the data until it finishes. Okay, so this will be 36, and I replace them all by the 36 over here. Okay, so for the missing data, and that's the reason why we can see the same thing happen in the RapidMiner when it's replaced for the missing data. Okay, now before I really build for my model, I will have to set row of the variable. So over here, right? If you go and take a look one more time, so you see like we will have to clarify the cell will be like the predict value, right? The predict attributes or predict variable we want to just focus on. So we use for all the other like ACD, country, browser, traffic, tenor, repeated visitor, and the cell values to just predict for about uh, the cell. Okay, so to do that we have to clarify about the set row. Okay, we have to set row of the data, so we will have to just let the RapidMiner understand that cell will be what we want to do for the level. Okay, we want to do for the level. Okay, so over here that should be good, and with this one I'm going to just use this and run it, and you can see right now, okay, for cell it's now become a like spectral data, like the spectral attributes, and in this one they know that cell will be like 0 or 1, 0 or 1, 0 or 1. Okay, so that means now the model has been already like got what we already want to just do with one. Okay, so let's go and build up for the model. First of all, to build for the model, we will not use all the 100% the data will be, right? We will have to just spread the data into the two different parts, the testing data set and the training data set. The training data set we use to create for the model, while the testing data sets will be used to clarify, to validate, to check for the performance of the model. Okay, so I have to split the data. Alright, and with this one I will just move them down here so we have plenty of more time. So I want to split the model by the automatic. I will just do it automatic, and the ratio will be like 70% and 30%. So they understand that 70% will be used to create the training data, and that's 30% will be created for the testing data. And you say okay. So if you go until this point, you can see that this data has been trained, right? They has been separated for two different ones. The first part will be like just from this original 825 observation. Now just 578 example observation will be used for the testing data set, and you can see about how all the thing about them has been like clarified over here. Okay, so that means data has been already created. If I click for two of them, you can see the two different split data, right? The first data set, the training data set, okay, and with this one just 247, this will be for the testing data set, and you can see like this will be exactly 30% of 825 observation. This will be exactly 70% of 825 observation. Okay, so this will be the split data. Now after I have split the data, I'm sorry, I will delete the command, and and I will use the model. So now here in this example, I will use three different models. The first of all, the logistic regression. The second of all, the decision tree, and the last of one will be like the neural network model. Okay, so first of all, I use the logistic regression. Okay. The second one I'm going to use for today will be the decision tree. Okay, and the last one that I'm going to use will be like another machine learning model. That will be neural network, artificial neural network. Actually, that we correctly will say like that, but I would just say neural network. Okay, and this will be three model based on three different algorithm of the machine learning, and we're going to try to see how they perform. Okay, so first I'm going to use the logistic regression, and I could drop them here and use the data. Okay, and with this one, if I just use this one, so you can go and see about the model and the result. Okay, so first of all, we have the problem. Logistic cannot handle the numerical values or numerical data. So what's the problem here? What will be the problem here? So you can see here, right? When you take a look into the data, the cell is 0 and 1, 0 and 1. The label here, that should be the numerical. However, logistic regression, decision tree, they are classification model, and they not really understand about 0 and 1. That means numerical variable. Okay, not the numerical variable will be not the main problem. That should be one of the main problem. So the label should not go into like 1 or 0, but they should be like yes or no, yes or no, yes or no, something like that. So we have to change one more time. We have to change about the label. So how we do that? Actually, it's quite a simple. So with here, instead of creating for the model with the label, I would change it from the numerical to binomial. Okay, numerical to binomial, and I will put them maybe over here. Okay, so I select here just one single variable. That will be the cell, right? And I would just change them into so I would just change them into the original data. So I change them into from the numerical. Now I change it to binomial, and if I run for that one, now it's got it, and the problem has been solved. So if I go and run for the model, so this is the original logistic regression model, right? You can see that the coefficient like A, the city, country, whatever, but you can see tenor or repeated customer, visitor. Like if a customer is the visited, so they will have very positive, or that means higher probability that they will become there. They will make a sale, or that means you can sell the problem for them. And the sale value, right? The other type stuff. So this will be the basic regression model. But however, with this logistic regression model, that will be not the thing I really care about. So the thing will be that I want to seek about the prediction in the futures with the testing data sets, right? So I will use the function apply the model, okay? And I want to seek about like based on the result. Okay, so based on the result, based on this result of the regression model, I put them into the model of apply model, and I put the testing data into the testing data set here, and I want to link them, and I want to see about the model too. So I want to check that how the performance of this logistic regression are doing. Okay, so if I run it, so the model is still here, right? Description is still here, and it's kind of a little bit complicated for you to understand, but you not really have to care about them. Go and see about the example data set. All right, see the cell. Now they check it for the confidence and the confident to be false and confident to be true. So if that's we want, that's we say like yeah, false will be correct, and then we just classify the cell into false. Okay, and the prediction is false. So the prediction is false. That means the this will be the our prediction, and this will be the cell will be the original data. Okay, so based on this model, based on all the information, they make all the calculation based on the logistic regression, and they predict that with all the information like that. The prediction about the customer will be the sale of them will be false, and that's very true compared to the real data. So false doesn't mean it's good. False doesn't mean it's good. False doesn't mean it's good. And for the data like it's true doesn't mean here that we predict like confident like true, and we predict that should be true compared to the original data or the real data that is true. So that means this model is doing well. Okay, so this will be how it's work. And you can use this model to just do that one, to just perform for all the kinds of other kind of stuff. Now let's try and see it with the other model. Instead of just logistic model, we will use the decision trees. Okay, and the decision tree we drop here and create is over here, the mode, and also for the testing data set too. Okay, so with here decision tree, I can change like the maximum depth will be like maybe 220 something, to just change it a little bit, and I'm going to run it. And one more time, this will be the decision tree. So if the cell values is high smaller than 12.5, that means this predict that our performance will be 0. Okay, will be false. If it's larger than $12.5, that's will be true. That means that will become a real customer, and they also do the prediction the same like what we are doing. Okay, and the same thing you can do with instead of the prediction. So you can use their neural network, and they can also create the same thing over here. Don't worry, because I normally for the neural network it will be quite a strong and take very long, but here we will just put them in default and we run them for one more time. Okay, so this will be the form of the neural network and how it could be deal with the nodes. But you don't have to really understand, worry about this one. Just go and check for this one, the result. So if the result will be like true and false, confident will be put more into the false, like 99.5%. They will be clarify them to be false for prediction. And compared to the real data, that's true. That doesn't mean they are matching. And the same thing we are doing. So we have to see about how all the model has been running on. Okay, but up until this point, you don't see any kind like the validation of the performance. We have the 3 different models, right? And we don't see any kind like how we can compare like neural network compared to decision trees and compared to the logistic regression, which one is better or which one is worse. Okay, so we had to perform a comparison, and this will be the time for us to just try and run and see about the confusion metric and about the detail about confusion metric, how it's going to compare between the prediction and the true story or the actual the kind of like the realistic situation or the original data, the real data. We have to see about what will be the difference here, how we measure for the kind of like all the criteria like accuracy rates, like recall rate or precision rates. I recommend you guys to just read about the instruction and also for the slide carefully about the confusion metric. But confusion metric tell us that how many percent that the model are doing well. That means that's predict correctly or if not predict correctly. So to do that, okay, with the apply model, now we can run and use for another one like what we say, the performance. Okay, and if you go and say about performance, that will help you to check for the model. And with the performance of the model here, as could be like classification on binomial classification. So classification is when the outcome can be so many, right? But here the outcome will be like just yes or no, 0 or 1. So that's be binomial classification. This will be better to use this one. Okay, so I just use this one and I put them this one into the performance. Okay, and I link them over here. Okay, right, and let's go and see about the result. So for the neural network, they are doing very well. Like, let's check about the accuracy. So the accuracy is 100%, and that means there is no like error type 1 or error type 2, and even all the prediction about that's false case, that should be 216, that's really matching with the original data or the real data. That means 100% of all the thing is correct, and that is so kind of suspicious. So actually with the data, right, when you do like that one, that means it's really so suspicious when your model is doing so well. And the same thing, I'm going to check it with the what's one, the logistic. Let's come back with the logistic regression. Okay, and let's just do with this one. And let's run and see about the accuracy one more time. 1 to 16, there are no error over here. All that's very true. So accuracy one more time with 100%, and there's the problem here. I'm really sure that there's the problem here. But what will be the problem? Remember about what I have already mentioned with you, right? When we use for the function like this, like cell and the set values, right? For cell and the set value and the cell values. So if you cannot sell for that customer, your cell value will be 0 too. That's true. But however, if you can sell them like something, right? You can sell them, that will become your customer, and that means you will clarify them like one, that means they become your prospect, and you can sell them something. So you have your sale like 25 or 55 or 90, at least some dollar, right? So that means if you can have the sale value, that means that one has already become your like customer. So sale value and sale, they like one, that should be the one relationship. So it's not so good to you for the sale value, because that does make the model become overfitting, and the prediction power is no longer a good one. So I think like with here, I will remove one more time. Beside of the guide ID, right, I will remove the sale value too, because I don't want to use them, and I just remove them, and now just the other variable will be used. And if I do it and run for one more time, you can see about the accuracy will be changed, right? Description. Now with the logistic regression, just 94.74. The regression will be this one. And you can also see about the recall and precision too. But that means there's some error here, right? For example, here you predict for like two of the example will be like true, but actually it's false. So two of them were wrong. Why the other? You predict like 11 of the example were false, but actually it is true. So it's not accurate. So this 2 and 11, this 13 observation, they are not so good for prediction. And for the other rest, like this 214 and 20, that means 234 observation, you accurately predict them about the performance. So that's why the performance of accuracy about like 94.74%. Okay, so this will be from the logistic regression, right? Logistic regression, and I would just say them over here. This will be the logistic regression, and I'm saying them over here, and yeah, I'm sorry, I would just paste them here. Okay, so we will go back and see about the result one more time. Now let's try one more time with the decision trees. So let's come back here, design, and remove for the logistic regression, but I will try the decision trees. and I link it over here. Man, model over here, the data over here. And one more time, decision tree, you can change whatever you want. If you want to see about this one, that should be good. Okay, and run. So now the performance, this will be the performance. We can compare them of this decision tree compared to the logistic regression and see like any color different. Okay, and the accuracy rate is about like 96.76. I will just make this one a little bit bigger for you to compare, and you can see this here, right? Even when they make it like something like 3, some error over here compared to 2, but with this one just 5 compared to 11. So in total just 5 plus 3, right? 8 of the example is wrong, wrongly predicted, while the rest like 240 like 239 observation is correct, and that's raise up the accuracy rate into like approximately 97% compared to 95% of the logistic regression. So that's doing very well, man. Okay, and the last one I tried with the neural network, and if you guys see like some deep learning model can really more proficient than the other, like the traditional other. So you use the neural network and apply for the model and link them with the data, and now let's just run it, and this will be the performance. Okay, so for the neural network, the prediction accuracy were about 94.33. So compare between 3 of the model, decision tree are doing the best, right? Decision tree with the very high accuracy, they are doing the best, okay, while the other logistic are doing the second and neural network are doing the third place. So you can feel a little bit confused, like, oh, normally people say like regression, like the new methods like neural network, they are doing much better than the other. Sometimes it's not. Yeah, so the accuracy about the performance of the prediction will be much more important than just the fancies of the model or something, right? So over here, okay, in conclusion, I have to show you how to just run for the performance of the classification model, and you how to see like I go through all the step by step, like first of all load the data into the computer, select the data, do some data cleaning process, and then I split the data, or what we say the data partitioning, and finally we apply the model and just benchmark them by the performance to see which model is doing the best, which model is doing not good. Okay, I hope that you guys enjoy for this video, and we'll see you later in the next video. Thank you so much.